Hi, welcome to #math. We're going to start analyzing polynomial functions with the intention of graphing them. And we do it by talking about their domain and x and y intercepts. So what are the two things that could make my function undefined? Do you remember? Yes, if we have an even index radical with a negative radicand, if you have the square root of something that has a variable in it, then you have to set the inside to be greater than or equal to 0 and solve for x. And that's how you find the domain. So the only good points you can plug in there are points that are bigger than or equal to 1. And if you have something like 1 over x minus 2, you have to take the 2 away from the domain. Take a look at these two examples. Is there any number we cannot plug in p of x because it would make it undefined? Well, no, we don't have even square roots, nor we have denominator, so we're fine. Same thing for f of x. So think of it. Polynomials doesn't have any problem. We can plug any number there because you can always raise any number to any power, multiply, add, and subtract, and that will not lead us to trouble. So the domain of any polynomial function is all real numbers. Let's talk about y-intercepts. The y-intercepts are the points where your graph touches the y-axis. In this example, this graph, you see that it happens here at the point 0 for x and 4 for y. So we set x equals to 0 to find where my graph touches the y-axis. Having a polynomial function, this is the same as when you set x equals to 0, is the same as evaluating the polynomial at 0. And if you evaluate the polynomial at 0, you get an 0 to the n plus an minus 1, 0 to the n minus 1 plus a 1 times 0 plus a 0. So this is 0, this is 0, this is 0, and p of 0 equals a 0. That means that for x equals 0, y equals a 0. So the y-intercept of any polynomial function p of x is the point 0, a 0. Look at the following question. How many y-intercepts can a function have? Can you answer that? Yep, only one. Otherwise, we would not have a function. So it is very easy to find y-intercepts because you only set x equals to 0. So the only thing you have to find is p of 0, which in this case is just 1. Because when you plug in 0 here and 0, you get 1. So the y-intercept is 0, 1. For f of x, the same. You do f of 0 to find the y-intercept. And when you plug in 0 here, here, and here, what you get is 0. So the y-intercept is 0. Because our intention is to graph polynomials, let's look at the graph of this too, and look at their y-intercepts. The y-intercept of p is here, and of course is 0 for x, 1 for y. And the y-intercept for f is here, which is the origin. Okay. Now, to find y-intercepts of polynomials, we don't have to FOIL. It's going to always be the product of the constant terms. Because when we plug in 0 for x, remember, to find y-intercepts, you set x equals to 0. So that means you're evaluating your polynomial at 0. So when you plug a 0 here and a 0 here, you get positive 2 times negative 4. So your constant term is negative 8, and thus your y-intercept for p is going to be 0, negative 8. For q of x, it's the same thing. You need to do just q of 0. And when you plug in 0 here, 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 we get the negative 3 that's in front, a negative 2, a 1, and a 5. And when we multiply, we get 30. So the y-intercept is 0, 30. So we don't have to FOIL. Now let's talk about x-intercepts. X-intercepts are where the graph touches the x-axis. And we find x-intercepts as always. We set y equal to 0. So to start analyzing this, think of a polynomial of degree 2, which is just a quadratic equation we're very familiar with. When you set y equals to 0, you're setting, remember y is p of x, you're setting p of x equals to 0, so you're finding the solutions to the quadratic equation x squared plus x minus 6 equals 0. And that we know how to do. Factor. The 3 has to be positive, then the 2 has to be negative, and then you use the theorem's property of the real numbers, which tells you if the product of two factors is 0, then either one factor is 0 or the other factor is 0. And then we solve for x, so subtract 3 on both sides, you get x equals negative 3, or in this case you add 2 on both sides, or x equals to 2. So the x-intercepts are -3 for x, 0 for y, and 2 for x, 0 for y. Those are my two x-intercepts. It is very important for our vocabulary to note that x-intercepts have various names. They are also called real zeros or roots. We say that the real zeros of p of x are, and we refer only to the x-coordinate, -3 and 2. The same when you're talking about the roots of a polynomial, you say that the roots of p of x are -3 and 2. Let's look at the graph. So in this example, our x-intercepts are -3, 0 and 2, 0, precisely where my graph touches the x-axis. So we have two roots or two real zeros. So in general, to find x-intercepts, we must factor the polynomial, then use the zeros factor property of the real numbers. Let's see another example. So suppose you have this polynomial. The first thing to do is to factor. So we go ahead and we notice that we can take a greatest common factor of x to the front, and we're left with 2x squared minus 7x plus 3. And then we factor the trinomial. This is x times, I need a 2x here, an x here, then a 1 and a 3, both negative, to make a positive 3. So we have our polynomial factor. And now we use the zeroth property. That tells me that either x is 0, or 2x minus 1 is 0, or x minus 3 is 0. And now we solve for x. We add 1 on both sides, so we get 2x equals 1. Then divide by 2 both sides, and we get x equals 1/2. Here we add a 3 on both sides, so we get x equals 3. So at the end we get x equals 0, or x equals 1/2, or x equals 3. So the x-intercepts of the polynomial p of x are x equals 0, of course y is 0, the pair 1/2, y equals 0, and the pair 3, y equals 0. So those are the three x-intercepts. Now the roots of the polynomial p are 0, 1/2, and 3, as well as the real zeros of the polynomial. And of course, let's look at the graph. So this is the graph of the polynomial p of x, and we have here the three x-intercepts, the origin, the point 1/2, 0, and the point 3, 0. Notice that the x and y-intercept in this example coincide. The only y-intercept is the origin, which is, of course, an x-intercept. Thank you.